Hi, I'm Xin. This is Jack. This is Lucy, and this is Easy. We built a waste classifier for our project. Hope you can join our demo.
Okay, hi everybody. So we built a model that basically identified different types of trash using deep learning, which might not sound particularly useful, but actually it is quite important. So throughout the world, we are producing more and more and more rubbish. That is predicted to rise through 2030 and 2050, according to The Economist, and they tend to know what they're talking about. And the way that we manage our waste is not particularly amazing. So in the UK, for instance, we recycle about 45% of our waste. In Germany, they recycle about 70%, so that's a lot better. So we could do better, and there's opportunities there in terms of how we manage our waste. But also, when we do recycle, so about 12 billion tonnes of waste was recycled in the UK last year, quite a lot of it is actually sent overseas. So when it does go overseas, it tends to go to large landfill sites. These are contaminated quite often. They often get shut down because they contaminate water systems, and often they are manned by humans who then go and sort the trash. These are pretty terrible working conditions. The people who work on these sites, they often have to eat in these very unsanitary conditions. They're often vultures. They tend to get injured. You can cut your hands on metal. They get very easily infected. This man here was blinded in one eye from acid, and often they have children working on these sites. So it's very easy for humans to identify different types of rubbish, but the process that we go through right now actually creates a terrible environment for people to work in. So we propose using machine learning, deep learning, to maybe start to develop machines that can actually start to sort our waste for us. And that's what we started down the path of doing. And Izzy is going to tell you how we did that.
Okay, thanks Lucy. So over here on the left-hand side, you can see the 6 classifications of waste that we wanted to categorize our waste into: paper, glass, plastic, metal, cardboard, and trash. You can also see that that data set is very clean. Like, all the backgrounds are very white, there's only one item in each of the images, etc. So while we did use that data set, someday, it would be great to have a model that was trained on something more like this data set, where there's multiple pieces of trash, there's backgrounds that are a bit more realistic, and maybe there's pieces of trash on top of other pieces of trash, and we can kind of separate those into understanding that there might be 2 different types of trash in there. So, well, let me go back to this. So we had like a couple thousand of those images right there, and then the next challenge was basically, okay, well, how do you take an image and feed it into a mathematical model? The mathematical model obviously needs numbers because it does a bunch of different linear combinations. Can't do that with a Funyuns bag image. And so what you have to do is you take each pixel of the Funyuns bag image, and as you all probably know, you can represent each color with a combination of red, green, and blue. And so you give the model 3 numbers, one for red, one for green, and one for blue, for every single pixel in that image. Obviously, that's a lot of numbers, and then we have thousands of images, so one pretty important step for the pre-processing is making the images slightly less high resolution, so we kind of make them a little bit blurry, but it's good enough for the model. Okay, so we've got a Funyuns bag, and then for every pixel we've got 3 different colors, and then we've got loads of numbers that represent that one picture. So then we fed it into our model, which we ended up using one called ResNet50, kind of similar to the Alzheimer's group. ResNet50 is a model that uses transfer learning, so it's already been trained on 14 million images, not of trash, but of like loads of things in our world, but kind of similar to how a kid learning about trash is going to like have an understanding of the world, and that helps them learn about trash. Same with this image model. So 14 million images, and then our few thousand images of trash. So a bit hard to explain what's going on here, even I don't totally understand it, but the initial layers are kind of understanding like the very broad outlines of things, like the curve of a water bottle or something like that. And then the understanding becomes more abstract as we get to the later layers of the model. We ended up coming up with a best accuracy of 86%, which we were really pleased with, especially because the training time was only about an hour and a half. You know, 2-week project, an hour and a half of training time. This could be much better with more time and more resources. So as I said, we did look at a couple of different models, and the main way that we used to understand which model was the best one was we printed out a confusion matrix for each one. And so you can see the idea with a confusion matrix is that we know the true label of all these when we fed it into the model, and then we know the predicted label that our model wanted to use. And so if we've got, you know, a actual glass piece, we're hoping that the prediction is also glass. So the ideal would be that all the numbers on this diagonal would exist, and then there'd be zeros in all the other boxes because those all indicate wrong predictions. So you can see that although we do have wrong predictions in our test data set, it's pretty good. So we were really pleased with this. I want to show you a quick earlier model confusion matrix that we had, because one thing we ran into, as you can see there, is that the glass column doesn't look that good. And we don't know why, because it's kind of hard to understand what deep learning models actually do. But we hypothesized that because we had a lot of glass bottles and also a lot of plastic bottles, the machine was having, or the model was having trouble discerning between the two. So our later model did kind of fix that, but you can see that there is still a little bit of confusion kind of going on in the same area. So we're really excited about the ways that this model could be improved in the future. It would be cool, as I said, to be able to identify trash that was overlapping with each other on different backgrounds, maybe include some sort of like tactile data, because even as humans, if we touch something, it's easier to tell what type of material it is. But we think it's a really great proof of concept, and we're proud of it, and Lucy's going to show you our demo.
Okay. So we created a kind of fairly simple interactive website that always needs refreshing when we start it. Refresh again. Help me. Okay, it's running. And essentially what it does, like when it works, we upload an image to it and it uses the model that has been trained. So the model is also hosted on the cloud, and that's what this website accesses. So every single time we put an image into this website, it goes to that model. Usually it shows you the image. I'm going to refresh it one more time. And then it will decide, based on the model, what it thinks the image is. We're having some connectivity problems. Okay. Woo. So I think we have, here's one we made earlier. So now the image goes in, and it will go through all of the same kind of pre-processing that we did in order to train our model. So, so all of the images became like similar size, and they all go through the same kind of filters, and they look a little bit like you would see on like an iPhone filter. So you would have like really strong contrast in some places, like really defined edges in others. And that's like part of the process that it goes through the convolutional neural network. And hopefully it will eventually tell us, ta-da, that this waste is indeed plastic. So I would like to invite my team members up. Shin and Jack, if you can come and join us, and we're very happy. Over there. Yeah, I definitely think that you could train a model based on that idea. With most of these kind of models, it's a lot to do with your data. And as long as you can find a way to clearly differentiate between two types of plastic and find enough data for that, I think it would definitely be possible. I think with different types of plastic, like thin plastic versus like thicker, clear plastic, with just image data, that would be probably quite tricky. But there is quite a lot of research going into today with using ways of like maybe squashing a piece of waste and then understanding how it responds to that and using that data to then do it. So there's definitely quite a lot of opportunity to use this like same kind of idea of having like identifiable characteristics and using that. So yeah, for sure.
Any other questions? Yeah.
Does the resolution of the image have a big impact on prediction values?
It would do. So anything that was like really zoomed in, I think we definitely had data like that.
Yeah, so we tried to use the more complex data set, and so we knew the location of items, but if something was like a flat of plastic on the ground, and then we added padding to it, you all know what padding is, because we wanted to get some of the background in for a realistic background, then it ended up being like mostly glass or mostly grass or mostly tarmac, and only a tiny like piece of plastic, so that was basically kind of useless. But the idea behind resizing, like if it goes from like 1,000 by 1,000 to then like 180 by 180, then that difference doesn't matter, but it does make the model a lot faster. So that's why we did that.
Thank you.
Is there anything you do if you have more time? You mentioned a bit of time constraint.
Yeah, we definitely can do more data pre-processing because, like Izzy mentioned, that the data we use mainly is one single piece of trash with white background. And what we can do is to do a random transformation of the color, the background, the contrast, and brightness of the picture. And that will definitely make the model more robust. And another thing is to use more complex data set, like with more messy environment, so that the model can detect the object and make classification.
Is there any other questions?
Just
Yeah.
in terms of how, I guess, cutting edge it is there a lot of other people which are doing similar things, or is this kind of you guys?
We're the first ever.
How difficult it was for you to turn around and do this, if there's other people doing this, or is it just like very difficult?
For me? Yeah, there's quite a few people doing it already, really.
It's still definitely an emerging technology.
Yeah.
There's definitely waste sorting facilities all over the world that are beginning to try this kind of technology, but it's definitely like emerging.
Would you be able to combine the visual data with other data? Because I mean, the fastest way I think to tell the difference between a glass bottle and a clear plastic bottle is a glass bottle weighs so much more.
Yeah, I think so, and I think image data, because that applies broadly across all the different categories, because if you think about the density of cardboard compared to the density of plastic, it's still quite similar. But that's why I said, yeah, I think it's MIT have been developing a robot that squashes or like squeezes the waste a bit to get that sense of like what it is, which that actually, if you think about the way that plastic moves, paper and other things, like that actually is quite intuitive. So I know that that's definitely one other way that people are looking at it. But those data sets are not public yet.
Any last questions? No? Okay, congratulations to you.